Hey friends, welcome back in the another series of unsupervised learning. So again, we will see all the technique of unsupervised learning. What are all the technique do we have in our unsupervised learning? So basically, we have done supervised learning series. Now we have seen that in supervised learning, we try to build a mathematical model using data that contains both the input and the desired output. But in case of unsupervised learning, it will contain only input with no desired output, right? So like in unsupervised learning, basically we have clustering and association rule learning, right? All these we learn under unsupervised learning. So first thing, the first topic that we have is again clustering. So again we have first, what does it mean? Like basically cluster is nothing but a grouping data, right? So again, unsupervised learning, we will be working in unlabeled, or here the target variable will be absent, right? So when we talk about clustering, again we will be working with grouping data, like making segment and group several data. Right now, cluster is basically also refers to similar collection of similar data objects, right? Let's say we have many objects. Now we want to group similar object in separate groups, so we can do that, right? We have various application of clustering, like we can use it in image processing, in medical domain, in customer segmentations, right? So it has a vital use as well. When we talk about especially clustering, so we have basically two types of clustering, like hierarchical clustering and potential clustering, right? So here before wasting our time, we will see what the k-means clustering is. So again, here basically we have the goal is to find a group or assign the data points to clusters, right, on the basis of their similarity. We will see in the example how that works. So let's say we have a domain here, that is banking. So we have a transaction detail of 515 banks, which includes number of DD taken, withdrawals, right, deposits, area of branches, and average walk-ins. Profile the banks into segment and come up with the recommendation for each other. So let's see how that works. First, we will do again importing our necessary library. So here we need pandas, we need k-means from cluster, right, to implement our k-means clustering, and of course the plt for plotting our plots. Here we are reading the bank.csv. again I'll be providing the link for the csv in the description, you can check it out there. Now checking the data, so data df.head, so calling top 5 rows of my data set. So you can see that what the data set is telling, that we have bank, right, we have dd numerical value, we have withdrawals, we have deposits, we have branch area in square feet, and we have a average daily walk-ins. Right now, if we get the data dot save, so you can see that we have 515 by 6. Okay, data df dot info, so here you can see that all these value and non values are here. Now checking summary of statistics, so here you can see data df dot describe function. So describe will return all the values like minimum, maximum, mean, count, right, standard deviation, and interquartile ranges as well. Now checking for duplicate, so here similarly we call df dot duplicated, right, it will check whether there are duplicate or not. If it is yes, it will return that, and then we are doing some summation of them, so that means there are no duplicates, right? So that is why it returned 0. Now scaling the data, so first we will import the standard scale module to for scaling our data, then creating an object for standard scalar function, so defining a variable and passing the function into that. Now now scaled df equals to x dot fit transform, so here we are fitting in that df dot ilog, right, it will work with all the columns sorry, it will work with all the rows and column from 1 to 5, right? So scaled df, if we return that, so you can see that the value that we are getting here. Okay, now we are creating clusters using k-means. So let's see how it works. Again, k is nothing but we have to define it by ourselves, what will be the value of k, right? So basically forming two cluster with k equals to 2. But sometime like you will also observe here, sometime it is very difficult, or we cannot easily identify what value should be for k. So there is a function, or we can say there is a method, we can do that by ourselves. We just need to do one formula, that is root n by 2, right? So that will basically give me the number of cluster uh, that I can define. So here I am just starting with 2. So creating k-means cluster and store the result in the object k-means. So k-means equals to k-means and clusters equals to 2. Now fit k-means on the scaled df. So k-means dot fit scaled df. So here you can see that we got this function called, right? Now cluster output for all the observations. So getting the label. So here you can see if we call only k-means dot labels, so it will return all the labels that k has grouped. Now within cluster sum of square, so k means dot interarea. So here you can see that we are getting that within cluster we have 1943, right? Sum of square is that. Now forming cluster with k equals to 1 3 5 4 5 6 and comparing with each and every one, right? So here when our k was 3, right, the number of cluster was 3, then we fit it, we got the interarea. So interarea is nothing but again within cluster sum of square. When it was 4, we got this value. When it was 1, we got this value. When it was 5 6, so on so forth. So here you can see that when we increase, like in case of 1 it was 2575, when we increased with 2, so it was 1943. When it was 3, it was here it was 2, right? Yeah, when we increase it with 3, so it was 1593. For 4, 1375. So that means wss reduces as k keeping increasing, right? So the highest value we got with 1. Now calculating wss for other values of k, here we are using elbow method, right? So wss again is nothing but within sum of square. So here we will use elbow, we are defining within square, right? Within sum of square as empty list, then for I in range 1 to 11, km equals to k means and clusters equals to I, km dot fit scaled df, wss dot append km dot interarea, right? So now we are calling this wss. So here you can see that after performing this for loop we got these values. Okay, and now if we plot this plt dot plot ranges 1 to 111, right, and wss, so here you can see that how it is plotted here. Now we try with k means with 3, so we have also done that right here. Now we are taking the k means dot label into labels variable. Let's see now cluster evaluation for 3 clusters, right? So the Shilhote score, so basically we have the Shilhote score here, we import it from matrix again, right? Now we normally use Shilhote score function we called and pass our scaled df and the labels, right? So if we talk about the Shilhote score by the k means, so here you can see that it is nearly 21%. When we have k means the value of k equals to 4, that means cluster evaluation for 4 cluster, then we got 22%. So it is slightly increased when we increase the value of k. So again Shilhote score is better for k cluster, that is 4 in our case, than for 3 cluster, right? So final cluster will be our 4 because we are getting better score of Shilhote. So this is how you measure that how the accurate we can make our k, right, by just following the Shilhote score. Now data df plus means 4 equals to label. Now I am applying that with all the our data set. So here you can see that the plus k means 4 you got here. Now in case of 1 it is 2, in case of 3 it is 3, in case of 4 it is 2. So let's do cluster profiling. Okay, so basically in cluster profiling we will make like this uh, data frame, right? So data df dot class means 4 dot value count sort index. First we are sorting it, then cluster profile equals to df. First we are dropping the bank column, right? The column permanently, the column here. Then cluster profile dot group by, grouping it by these cluster k means 4 that we just generated and its mean value, right? Now cluster profile frequency equals to data df dot cluster k means 4 dot value counts dot sort index, right? And here cluster profile we are calling it. Now cluster 0 that is small size bank with less deposit but highest walk-ins and withdrawals and large dd. Cluster 1 medium size bank with less walking and deposit and high withdrawals. Now cluster 2 medium size bank with less withdrawals, walkings and dd but highest deposit. And cluster 3 we are using large size bank with more number of walk-ins and highest dd but less deposit, right? So this is how we got the 0 1 2 3. So here you can see that all the small size bank with less deposit, right, but the highest walk-ins here and the withdrawals, right, and large dd as well. Similarly you can map all these points with this frame. So there are some recommendation that we also observed when we were doing this notebook. So the banks in cluster 3 has high dd, right? Here you can see that it is even highest, right? So it need to improve in making the cluster deposit more. Relatively large number of customers are visiting these banks, so can promote various deposit scheme to these customers, right? Second is customers in cluster 3, that is this one. Seems to prefer payment through dd as these banks record the highest dd rate. Yes, banks can check that if dd is being made to other bank or to the same bank, right, and can look to create a dd scheme for their own bank. So that customer will open their account with this bank and use the dd payment scheme. Now customer performing dd payments can go to banks either in cluster 3 if they need large space which can manage a large crowd probably with more infrastructure facilities, or cluster 0 if they want a small space where probably quick transaction can happen due to less crowd holding capacity. Now size of the bank doesn't matter in accommodating large group of customers inside the bank, as cluster 0 though having the least branch area has the highest daily walk-ins, right? So banks don't need to invest more in occupying large land space. So these could mean customers are visiting throughout the day rather than a large group of customers visiting during a period. Now cluster 2 is that is it has large area and the proportion of withdrawal and deposit is almost equal. Most of these customers could be having a saving account since the withdrawal as well as dd are less when compared to the other cluster, right? And customer visiting these banks are also lesser than other clusters. So these banks can look bringing in more customers and increase the bank deposit by introducing various deposit scheme. If we see 6 point, deposit is again less while the withdrawal are much higher for cluster 1. So these bank can also look to introducing new deposit schemes, right? And the banks in cluster 0 and cluster 1 needs to focus on their infrastructure and banking facilities, right? So if we talk about the square feet they have, right, and since the area is lesser than cluster 3 and 4, whereas daily walk-ins is the highest, so this bank can also look for opportunity to cross sell product to the customers. So this is how we can do some analysis on the basis of our k-means clustering, right? And the Silote score that helped us a lot to choosing our right value of k. Okay, so this was all about this video. Hope you liked it, right? If it is, then please do like, share and comment, so that will motivate us to come up with more content related to AI, right? Thanks, have a good time.